In this problem from MGF 1107, the question asks us to determine a spanning tree for the graph to the right. So in this problem, they give us a graph which has many vertices and edges, and we are asked to construct a spanning tree. Now, one thing you should recall is a tree is a connected graph which does not contain any circuits. And since it is a connected graph that does not contain any circuits, we should be able to come up with a path from any vertex to any other vertex in the graph. So if we look at our examples here, there's three options for a spanning tree. Now there are actually many spanning trees for that graph, but since this problem is given through the computer, you cannot draw your own, so you have to select one in a multiple choice setting. So it says, which of the following is a spanning tree for the given graph above? So option A is definitely a subset of the graph given, yet it is not a tree since there is a circuit all the way around that graph. So again, the circuit A to B to C to F to G to K to J to N, M to L to I to H to D to E to A, that's a circuit. And in a tree, you cannot have any circuits. Now B, if we look at B, it's connected because there is a path from any vertex to any other vertex. Now that doesn't mean there's an edge from every vertex directly to another vertex, but there's a path. And if you look at B, option B over here, there are no circuits. So it's a connected graph where there is a path from every vertex to every other vertex. Some of them are long paths, but there is a path, and there is no circuit. Now, thus that is a spanning tree. Now, if edge FJ was in the graph, then that would not be a tree because we would have a circuit right there. But FJ was not an edge in the graph. Now C, option C, is not a spanning tree because it's not connected. Here we have a piece of the graph all by itself, thus there is no path from L to B. So from L to B, there is no path. Now, if LM was an edge on the graph, then there would be a path from L to B and from every vertex to any other vertex. But that edge, LM, is not part of the graph. Or if DH was an edge in the graph, then there would be a path from L to B and from every vertex to any other vertex. But you couldn't have both DH and LM because then we're back to the problem in A of having a circuit. So if either DH or LM or I think this is EI, if any one of those was an edge in the graph, then that would be a spanning tree. But since it's disconnected now, it is not a spanning tree.